The core functionality of Scleralink is to design a quadrant-specific contact lens which will best fit the topography in an eaglet eye map. And to understand that and have a sensible conversation about it, I think we need to look at some terminology and some structures which relate to how it is that these modern scleral contact lenses fit on the eye. And I especially want to look in this short presentation at the management terms which look at the management of the lens-eye relationship, as I will call it. So here is a schematic which shows a scleral contact lens and an eye, and the lens is resting on the eye. And I want to look at the control parameters which determine what I would call the lens-eye relationship. And the first and most obvious of these is identified variously, but I will call it the apical clearance, which is the distance between the back vertex of the lens and the front vertex of the eye. And usually this is expressed in microns, and typically we see numbers of perhaps 250 to 350 microns as being an ideal starting point for a new fit. So that's the apical clearance. Now this parameter here, this control parameter, introduces us, although we might not be aware of it, it introduces us to the landing diameter and the sagittal height of the lens at that landing diameter. Now, the landing diameter is the most important dimension on any scleral contact lens, and it's extraordinary that you hear so little about it in manufacturers' literature and in general, for example, at conferences in relation to these lenses. You almost never hear this mentioned, and this is the single dimension which controls the fitting of these lenses on eyes. And the two dimensions here, the landing diameter and the sagittal height at that landing diameter, almost define what you might call the fitting ball, which is the area encompassed within the lens surface between whether it touches there all the way around to where it touches there. And it almost defines that, does not quite, because another control parameter which has impact upon that is the limbal clearance. Now, the limbal clearance is the clearance between the lens and the surface of the eye at some specified point, which may vary from manufacturer to manufacturer, along the approximate limbal horizontal visible iris diameter, that sort of area of the lens. And those of you who are skilled in the art will appreciate that you could, for example, have more than one such control point. And the third one is the scleral zone, which is often referred to as an alignment zone, which is the area of the lens which rests on the sclera. And again, if you're skilled in the art, you might appreciate that it may not be a single zone. In fact, it may be subdivided, and it may allow you to, for example, have primary alignment there, and then perhaps some standoff towards the edge, that sort of thing. So you can subdivide this, as indeed you can subdivide the limbal area for control points as well. And those are the three control points. And if we look in, for example, these three typical manufacturers' brochures here, we see that that is what you get. So you have in this pink one here, you have central vault, limbal clearance, and scleral alignment. Again, the alignment word being used. And this one here, central zone, limbal vault zone, and scleral zone. And here we have diagrams showing us, again, the central, the limbal, and the scleral alignment. So these are the control points which are used extensively to tell you how it is that this lens should fit on a particular eye. If we look at the lens from the back, we're viewing this from the back, looking into the lens from the back, we have the optic zone located centrally. And of course, sometimes the optic zone may be displaced depending on the clinical requirements of the particular patient. And in this case, and greatly preferentially, I have surrounded this by two peripheral zones. The first peripheral zone is shown here in blue, the second peripheral zone is shown in green, and the transition between those zones is in this case here, the limbal clearance control point. And having two peripheral zones in this fashion allows me to adjust the limbal clearance without having to alter the optic zone or its radius or anything related to it. So I can move the limbal area, the clearance at the limbal point, up and down without changing the optic zone. And that's a very good reason for having two, at least, peripheral zones surrounding the optic zone before I get to my scleral or my landing zone. There it is. And strangely, you will find lenses and trial sets where there is just a single peripheral zone, and in such a case, if you wish to adjust the limbal clearance, you will also frequently have to adjust the dimensions of the optic zone. Now that would be something that I absolutely would not wish to do. So this the basic layout of a standard scleral lens should be at least this, in my view. There we are. The scleral zone, of course, is defined in ISO as the zone of a scleral lens designed to lie in front of the sclera, and that's what we've got here. And in our case, we can adjust the standoff at the edge by suitable steps. So I want to then, having identified these control points, I want to see which of them apply in the case of the freeform lens in the Scleralink software. So first of all, this is again a schematic, and it is intended to be a quadrant-specific lens, so I have 4 quadrants, and I've identified those as Q0, Q90, Q180 and Q270. And you can adjust the apical clearance. Now you'll appreciate that to do that I will have to adjust the sag at the landing diameter, which is here, where at the beginning of the scleral zone there, like that. So I can adjust the apical clearance to suit myself, and in each quadrant I can then adjust any one of the 3 yellow spots here. I can adjust the limbal, the sag at the landing diameter, which of course may impact upon the apical clearance, and the sag at the total diameter. So having landed, I can move the edge of the lens up and down a bit. So I have a very extensive range of controls, which we will see in action in the freeform lens in the Scleralink software.